So if you can see the screen, actually, not yet. Let me go get the slides out real quick. Okay, so now I share my screen. So if you can see the screen, say yes in the chat. If you cannot, say no. Okay, so everybody can see the screen. Okay, very good. Let's continue. So now we are solving inequalities. So last lesson we were solving just the linear inequalities. Today we will be talking about compound inequalities and inequalities with absolute value. So a bit more complicated, but first let's do our homework questions. There are only 3 this time. So we have negative 52 is less than 2 times 3x minus 2. So this is quite straightforward. Use your distributive property, and then you should get the correct answer. All right, so let's see if we have any answers. So I think most people said greater than or greater than negative 8. So who wants to volunteer for this one? Raise your hand if you want to volunteer to solve the problem. Okay, Ivan. Very good, Ivan.
So
How
first,
did you solve this?
I distributed the 2 to 3x minus 2 to get 6x minus negative, no, 6x minus 4. And then I added 4 to cancel out the negative 4 and added 4 on the other side to get negative 48 is less than 6x, and then divided by 6 to get negative 8 is less than x.
All right, so that just means x is greater than negative 8. Okay, so now let's go to interval notation. So how did you solve this using interval notation? What would this be in interval notation?
So you have the open dot, and then
Okay, that's the graph. So we can do that also, the open dot and pointing to where?
to the right.
Okay, right. That's correct. And now the interval notation. How did you do the interval notation?
I think it was parentheses.
Yes, parentheses.
Negative 8x parentheses.
It's negative 8 to infinity because x is greater than negative 8. It's to infinity because anything that is greater than negative 8 fits the guidelines. So it's negative 8 to infinity. So you're never going to have x in the interval notation. It's going to be just numbers.
Yeah.
Now, let's go here. Number 2, 7x over 2 minus 2x is greater than or equal to 36. So I'm going to give you a couple moments to put your answer in the chat. So whoever answered last question, I think most people, actually everybody got it right. So Yuchen, Ella, Aaron, all got it correct. That's good. All right, so let's look at the answers here. So I think most people um got x is greater than or equal to 24. Actually, all of you got x is greater than or equal to 24. That's very good. Everybody got the correct answer. So now, who wants to volunteer? Let's ask a different person this time. Denny? Okay, very good, Denny.
So we can times 2 to get 7x minus 4x greater greater than equal to 72. And minus the 4x we get 3x yeah greater than 32. Um so it's so I divide 3 to get x greater than equal to 24. And it's a closed circle and
That's correct.
move to the right. And then the interval notation is 24 to infinity with bracket.
There you go. Very good. Okay, so hopefully everybody understands this. And now let's go to the third question. All right, let's check back here. See what you put for answers. So I think most of you got x is greater than 29. So all of you got a greater than 29. So let's find someone else here to answer. Ella, do you want to answer?
Sure.
Okay, so how did you do this?
I first I did 3x plus 4 is greater than 91 because I multiplied 13 by 7.
Yeah.
And then 3x is greater than 87 because I subtracted 4 from both sides. And then divide 87 by 3x is greater than 29.
Okay, very good. And how do you graph it?
Open circle, and then the arrow pointing to the right.
Okay, very good. And then how did you do the interval notation?
Parentheses, I think, and then 29, comma in.
Okay, very good. So that is all for the homework today. I think everybody got it very easily. Everybody got the correct answer. I don't think anybody had any trouble with this. That's very, very good to hear. Now we'll go on to our new stuff for today. So this is quite important, so make sure you take notes on this. We're first going to learn about compound inequalities, which is the conjunction of two individual inequalities joined by and or or. All right, so you'll learn what that means. So here's what I mean by and or. Okay, so when you have and, you can have x is greater than -6 and x is less than 4. Okay, so essentially what you're doing now is you're taking the intersection. Whenever you see and, you take the intersection. Okay, but I'm not going to talk about that on this slide. I'm going to talk about it on the other slide. Okay, so let's see here. We can also have or, right? We can also have or. You see, x is greater than -4, or x is less than -6. Okay, see how they can't coexist, right? X is greater than -4. It could be -3, but -3 is never going to be, less than -6. When they can't coexist like this is going to be or. So or separates these two inequalities, right? You're just gonna have to solve them, side by side, just like that. But when you have x is greater than something and x is less than something, and they can both coexist, it's and, you can solve them together, and I'll show you how to combine them in the next slide. So now we have and inequalities. Let's find an example, right? Let's say that 2x plus 5 is less than 5, okay? We have and 3, let's say 3x over 4, okay, is I don't know, it's greater than actually, can we do this? It has to be like the same. Actually, we have to do the same thing here. I don't know if that actually works, because now we have to do like this. We have to have the same thing here to combine them. All right, so a simple example here on how to combine these compound inequalities. So when you have the same thing, same identity here, and you see these things can both coexist, right? It can be greater than -6 and it can be less than 5. All right, so then you can combine them. So 2x plus 5 is in the middle, like this. And you combine them, that's why it's called compound inequalities. But you can only do this when it is an and inequality. You cannot do this with a with a or inequality. You cannot do this. Okay. So how do you solve it when it's combined like this? It's actually really easy to solve it when it's combined like this. You just do the same thing to both sides. So 2x plus 5, to get rid of the 5, you want to get closer to x, right? You want to get rid of the 5. To get rid of the 5, you just have to move 5 to both sides. So you do this 5, okay? Get -6 here, okay? Then you subtract 5 here. Subtract 5, okay? So as you can see, you just subtract the 5 on both sides. You know, the same thing, same thing. All right, do the same thing to both sides. And what you get here is -11 is less than 2x is less than 0. So now you can divide by 2. Okay, divide 2 for all sides. And then you get this. Okay, -11 over 2 is to 0. Okay. Whenever you have and inequalities, it's going to be enclosed. It's going to be like one interval. Okay, it's going to be one interval. It's going to be like a closed range, right? Because as you can see, 2x plus 5 is in between these two numbers. It cannot be out of these two numbers, right? So you know that x is also going to be in between two numbers. However, what if you know, that doesn't work? Okay? What if you have, you know, something else? 2x plus 5 is less than, okay, -6. It's not greater than -6 this time, it's less than, or we can have 2x plus 5 is greater than 2. So obviously, these can't coexist, right? For example, a number cannot be greater than 2, but also less than -6. That's why it's an or inequality. They cannot coexist. That's a core or inequality. So now you have to do them separately. If you do them separately, you just have to solve each one by its own. So we can solve this one. 2x is less than -11. X is less than -11 over 2. Okay. And now 2x is greater than -3 here. X is greater than -3 over 2. So obviously these cannot coexist, right? So that's why it's or. You cannot combine them. They go in separate directions, right? You see the number line here. The and inequality has this type of number line. Okay, you have -11 over 2, 0. And then you have open circle here, open circle here. See how it's closed interval? There's no arrow, it's closed, okay? Now, if you look at this graph, it's different. See, this one is less than -11 over 2. So you're gonna have going this way and then going this way. Okay, so how do you combine them or write them in interval notation when you have two different intervals? Okay, that's where this comes in, called a union. All right, so you don't have to worry about too much about it yet. It's just simple notation. So you have one interval, you have another interval. Okay, you take the union, it's just you draw a U between them. That's basically says it combines the two intervals. Now let's talk about union and intersection. And is called an intersection. All right. So when a number has to be less than 5 and also greater than -6, it has to meet both guidelines, right? So that's, you intersect those guidelines, okay? And that's an and inequality. Now let's look at or inequalities. These guidelines are in different ways, so you can only accept one guideline. If you accept the other, then it doesn't make sense, right? So you use a union for that. Or, okay? So are there any questions so far? If there are no questions, then I will continue. Okay, so now I can actually, yeah, we can talk more about the graphs here. So let me just draw this for you. So the x is and inequality. When, you know, x is in between -a and a, okay, you're going to have this. -a, closed interval. And you have an or inequality, okay? X is greater than a or x is less than -a, you're going to have this, okay? Like this. They go in separate directions, okay? And you just saw the interval notation. You know, this will be -a to a, but this one will be -infinity to -a union a to infinity. Okay, I can't write anymore. -infinity to -a union a to infinity. Okay, so now let's talk about the visual representation of what an intersection is, you know. Okay. So intersection, you have to accept both conditions. We can have one circle here, one circle here. What is the intersection? It is this middle part here. If you ever saw a Venn diagram, something like this, I'm sure you have in school, okay, then it will be like this. The middle is basically the both section. The middle meets both categories. That's called an intersection and is affiliated with the and inequality, because as you can see, x has to be less than a and greater than -a. However, when it's an or inequality, you can choose which condition, right? So you union, okay, two things. You add them together, okay, like this. That's a union. It's basically, you know, combine two things. So don't worry too much about, you know, the notation. Just remember this U for union, okay? We're not going to be doing too much set theory or anything. Just like, yeah, just combining the two intervals. Okay, are there any questions so far? No questions? Then I will continue. Now let's build on our knowledge. Okay, we already talked about this. Okay, let's build on our knowledge of compound inequalities with absolute inequalities. So what an absolute inequality is pretty simple. An expression with an absolute sign and an inequality sign, you know, simple definition. Okay, so what an actual example looks like would 3x minus 5 over 4 is greater than 5. Okay, so then you solve, you know, 3x minus 5 is greater than 20. So now where do you go, right? See, you can't just solve this like normal because there's an absolute value sign, and the absolute values are actually pretty tricky. Because absolute values, when you plug in a negative number, right, it is still positive. So you have to be very careful with this. There's many outcomes. That's why we can turn an absolute value inequality into a compound inequality. Let's see how that happens. So, definition of absolute value is basically, you know, it is the distance from 0 on the number line. So, always positive. I'm sure you already know that. So I can talk about the algebraic definition, okay? Square root of absolute value of x, okay, is equal to x if x is greater than or equal to 0, right? Or negative x if x is less than or equal to 0, or just less than 0, okay? So that is the conditional algebraic definition of absolute value. We don't really need to know this much for absolute value inequalities, but it is good to remember because we will be working more with absolute values later on, and you need to remember, tricky parts about the absolute value, right? So let's continue with how to solve absolute value inequalities. Actually, I don't even have a slide on solving. Okay, let me just put the definition up there smaller. Okay, and then I'll teach you how to solve it. Let's just write this again real quick. Okay, so what do you do when you have let's say absolute value is less than something? Okay, so let's talk about that. Let's say absolute 2x minus 3 is less than 5. Okay, when it's less than something, you can turn it into an and inequality. Okay, when it's less than, only when it's less than. Okay, as you can see, absolute value, less than sign, number. When it's in this format, you can turn it into 2x minus 3 is less than 5 and less than negative 5. Why? Because absolute value is the distance from 0, right? So if the absolute value, the distance from 0, is less than 5, then you know what's inside the absolute value has to be in between negative 5 to 5. Okay. So now you can turn this into a compound inequality only when it's less than a number. Okay. So now you can go here, you can solve negative 2 here, 2x is less than, 4, less than negative 1. Okay. Actually, it's just x. Okay, so now, you have, again, closed interval notation. So what about if it's greater than? Then you can turn it into an or inequality. It's greater than 5, right? So what happens when something is greater than, when the absolute value of something is greater than 5, right? So if you plug in 6 and you take the absolute value, it is greater than 5, right? If you take the absolute value of negative 6, it is also greater than 5. So we can visualize this, okay, like this. You're gonna have a really big, or I don't know, really, really big number that's negative. Okay, so basically a really small number. Okay, and you take the absolute value, it's going to be a very big positive number. So of course it's going to be greater than 5. So when you have absolute value greater than something, it's going to be, diverging like this. So when you have this, of course, you're going to have to use an or inequality. So you're going to, 2x minus 3 is greater than 5, and 2x minus 3 is less than negative 5. Okay, so you're going to switch the sign here, and then you're going to add the negative to the 5. Okay, so the two cases here. 2x minus 3 is greater than 5, and 2x minus 3 is less than negative 5. Okay, so now we can solve. 2x is greater than 8, x is greater than 4. 2x is less than negative 2, x is less than negative 1. So now we have negative infinity to negative 1 union 4 to infinity. Okay, are there any questions? If there are no questions, then I will continue. So now we don't need to talk about graphing because you already know compound inequality graphs, right? So once you solve the absolute value. It's just compound inequality graph, right? But let's use this slide instead to talk about special cases. Special cases. 2x minus 5 is less than negative 2. Okay, so Yu-Chen, can you help with this?
So what?
Yes. Okay, so are you able to solve this? Just really
Yeah.
quick, like a demo.
So the absolute value of x would be x if x is greater than 0, or negative x is less than 0. So
Well, what happens when we have, you know, when we have this
it's
less
less
than?
than a negative.
See, exactly. Okay, so you have to observe here. Can absolute value be less than negative? Can you really solve this? If we solved it like this, all right?
No.
If you solve it like this, we can't have that, right? So you have
Yeah.
to observe here. Absolute value less than negative
Yeah.
can't happen.
Absolute values can't be negative unless you put a negative sign in front of the absolute value signs.
Yeah, that's correct. So what happens here? No solution. This is no solution.
Yeah.
So don't even waste your time trying to solve this. This is no solution. So now, Yu-Chen, can you look at this other special case here? Negative 2x minus 5 is greater than negative 2. What happens here? So an absolute value is always positive, right?
So yeah,
So
x must be greater than 0 here. The absolute value must be greater than or equal to 0 here. It can't be negative 1 or either.
well, actually, an absolute value is always positive or 0, right? So that means
Yeah.
it's always greater than negative 2. No
Yeah.
matter what you plug into here, it is always greater than negative, which means, what is this? It is all solutions,
Yeah.
all real numbers, okay? So
Yeah.
here you can just say negative infinity to
Yeah.
infinity. Here you can say empty set.
Yeah.
This is undefined. Okay, very good. So remember these special cases in case you ever, come across these. Don't waste your time trying to solve them. You can immediately tell, right? No solution or all real numbers, so make sure you note these down. Okay, that's very good. So now let's go on to the actual practice problems. And we don't need to, let me see how many practice problems we have. Okay, so here, so we don't need to graph it yet. So we don't need to graph it. We'll graph it later. Okay. So now let's just work on solving the absolute value and then yeah, putting it into interval notation. Okay. Okay, let's look at the answers. So, greater than or equal to 38, less than or equal to -8. Let's see this. So, you have, this. Okay, so if you got a closed interval, you should not have gotten a closed interval, right? Because it is a greater than or equal to sign. That means it is an or inequality. So we can put this into x is greater than or equal to 38, or it is x less than or equal to -38. And the interval notation, this bracket actually, brackets. Okay, like this. So let's continue here. Let's look at this answer. Okay. Ella, you cannot hear me? Is it a problem with your...
Oh, I can hear you now. Sorry.
Okay, anyways, greater than 17 and less than -13. Okay. Aaron says greater than 13 or less than -13. Okay. Let's see what we have here. So we have x minus 2 absolute value over 3. We have x minus 2 is greater than 15, or x minus 2 is less than -15. Okay. So x is greater than 17 or x is less than negative 17. Actually, no, it's less than negative 13. Okay, so our interval notation will be negative infinity to negative 13 union 17 to infinity. Thank you very much. Okay, so now let's go number 3 here. Let's look at the answer here. Actually, there's no answers yet. So let me wait some more. All right, let's look at this. Okay, so Yuchen says no solution. Okay, let's look at this then. X minus 5 absolute value is greater than negative 1. Okay, it's actually not no solution. Because when you divide by the negative here, you flip the sign, okay, to do this. So it's going to be a compound inequality like this. You add both 5 to both sides. Okay. So you should have gotten 4, 6. So again, the important part here is when you see the less than sign, you have to turn it into a compound and inequality. Okay. So now let's continue. Graph the answer. Okay, so now we can graph the answer. So our answer was infinity to -38 here, so we can graph it. Pretty sure it was inclusive too. We have -38, 38 here. Okay, so again, open circles, and here's the key point of, or inequalities. Okay, or inequalities. They're going to be diverging the graph. All right, it's not going to be a closed interval. It's going to be two arrows pointing away from each other. That's the or inequality. Now, graph the answer from the second practice problem. Okay. We have -infinity to -13, 17 to infinity. So we have a closed circle this time. Again, it's an or inequality. So we're going to have these two arrows pointing away. So there's actually not, there is another one. So graph the answer to the third practice problem. We have a closed interval this time, so it's going to look different. We have 4, 6, closed circle like this. Okay. So key point here is the or inequalities, they're gonna have two diverging, arrows. Okay, but the inequalities, you're gonna have a closed interval like this. Okay. So are there any questions? If there are no questions, I think that is all for today. All right, so I've already posted the homework. So yeah, let's see how it goes. So thank you for coming, and I'll see you next time.
Thank you. Bye.
Thanks. Bye.
Thank you. Bye.